Good afternoon. My name is Len Charney. I'm the Dean Emeritus of the Practice Department at the school and currently serving as Special Presidential Assistant for Strategic Research. It's going to be my pleasure over the next hour to host a conversation with Anas Kassas. Anas is a 2017 MArch grad who went on to found his own brainchild company, INOVUES. INOVUES is a building technology company focused on commercial building upgrades and energy efficiency retrofits. His company has progressed from a rather unknown startup to an expanding company with established venture capital support, national recognition, and a growing list of commercial real estate clients and build projects. I'll also acknowledge at the beginning with a certain amount of pride that I got to know Anas better when he was first tipping his toe in the proverbial entrepreneurship water. In the fall of 2015, several semesters before he graduated, the practice department sponsored a pop-up business incubator course and competition with a small amount of repurposed grant money. The initiative was called the Hatch Project, appropriately. 5 groups of students met for an intensive month to explore the connections between design and entrepreneurship with the express goal of incubating their ideas into action. I think it's fair to say that Anas was a poster child for this pilot, and I'm delighted that he's taken the trajectory he has, and he's back here to tell us, and so we all can benefit from it. I'm going to ask Anas to start off by describing the evolution of his company and where it is today. Then have him share some of the most important lessons learned for those of us in the audience who are entrepreneurial and want to have a better understanding of how to get started on something like this. And also, in preparation for today's session, Anas and I spent quite a bit of time online where Anas was reflecting on how he feels the BAC can encourage and support entrepreneurship as a matter of course, an essential element of every student's educational experience. And he's going to share some of those ideas with us. And finally, we'll make sure to leave time for answering any questions that those of you in the audience have for him. And so without any further delay, it is my pleasure to reintroduce the BAC community to Anas Kassas. Anas.
Thank you very much, Len, for the intro. I appreciate it. And it's really a great opportunity to be back and talk about the journey so far. As you mentioned, it started with the Hatch program, and that was a great moment at the time in 2015. I had the idea for just 3 months, and I saw the announcement for the Hatch program and spoke with Jack Cochran at the time, and I was very interested. I applied, had barely a few lines to write about the idea, and ended up being selected, and that was history. It was a very great experience. I'd love to share my screen and show people a few slides that could help kind of explain what INOVUES does and how the journey started. So let me just let me know, Len, if you can see my screen so I can make sure.
Absolutely, you're online.
All right, perfect. So yeah, I'm really excited to tell you more about what we do. So INOVUES makes buildings more efficient and sustainable by retrofitting the facades and windows with the latest energy saving and smart glass technologies without replacement or disruption. I founded the company in 2017, so everything before 2017 was basically just pure early research and kind of market research and R&D. Right now we're headquartered in Houston. We recently expanded to New York City, and our product has been installed on buildings in Boston, Seattle, Los Angeles. We've won a number of awards, went through several kind of clean tech accelerator programs for startups. We got backed by some of the great investors like Saint-Gobain, the world's leading building products and materials company. Got selected as one of 50 early stage companies in the world by Clean Tech Group. It's been quite an interesting journey over the past few years. but yeah, I mean, if I am to show how everything, started, so I graduated from Damascus University in Syria, did my bachelor's degree in architecture, and went to Dubai, worked for like 3 to 4 years at the intersection of architecture and facade engineering and fabrication, and then moved to Boston, did my master's of architecture there, worked for a number of interesting companies like Moshe Safdie Architects, and then this is where the idea started in 2015, and then continued. My thesis was about the topic, and then I moved to Houston, started the company, and this is how it went through. I want to show you, the whole thing started when I was in Damascus. The first I had a fascination for dynamic building facades and kind of smart building envelope technologies. And at the time, the first attempt, kind of serious attempt, was my bachelor's degree project. And at the time, it won an international award. It was a mechanical system. It was for a renovation project, actually. So it was still in kind of targeting existing buildings. It was a mechanical system, very challenging. Can transform into 108 positions to better filter light and heat and views. But the challenges that I encountered while developing this system made me want to go into sort of an untraditional path. So after graduating, I didn't work for an architectural office. I went and worked for a specialty glazing contractor and fabricator, where I had to learn about the kind of engineering side of facades and the fabrication as well. And that kind of gave me kind of a multidisciplinary experience. From there, I went, worked for some of the major international companies, like you can see here, some of the high-rise buildings in the Middle East, and learned about all things related to curtain walls and insulating glass and how they're fabricated and what goes into the design, engineering, and simulation of these kind of systems. And then went back to architecture and joined an architectural firm, but was the lead on facades. So any new project, especially high-rise buildings, I would lead the development of the facade systems and the building envelope. And then after I moved to Boston, wanted to do my master's in architecture again, and at the time I also joined Moshe Safdie. But before moving there, this was still, in terms of, this was one of the projects, but facades were still, one of the main, points that I'm interested in. So this was like a double skin facade. So I was always trying to learn more about the new technologies and how things are being done. From there, joining Moshe Safdie was also very interesting. So also was, my experience in Dubai in facade engineering led me to work on a major project in China, 10 million square foot, gigantic project. You can see here the ships, the scale of this. And I was responsible for the podium facades. And you can see like here, one detail, worked for a year on this project, one project, and a lot of things that I learned about. From here, after 1 year at Moshe Safdie, when the project ended, I wanted to take like a few weeks off and kind of think about the next steps, and that's where I started, thinking about what kind of ideas I can come up with that I can address some major problems and help, bring a new solution. And I thought, my experience in architecture and facade engineering is kind of rare. And I was once sitting in my apartment looking at the windows, and I started thinking, how can we transform these windows into smart and more energy efficient systems without having to replace them, without having to do any kind of disruptive or invasive procedures. And started looking online and doing some research, and didn't find any real solutions to the problem. But at the time, I learned about the energy efficiency problem of existing buildings. And I want to skip through to some of the to this slide, and when I saw this image for the first time, it's a thermal image of New York City, and you can see the level of impact that the building envelope contributes to the energy consumption of buildings. And it made me think that as architects, we try to focus a lot on new construction and building new buildings, but there's a huge problem that existing buildings have, and they are like the number one energy consumer in many countries. So started learning more about the energy efficiency problem, and that got me to back to the chart here, where moving into the idea, start thinking, okay, what if we can add another pane of glass on top of the existing windows? And this pane of glass could be any type of glass, can be smart glass, or it could be energy efficient, entry-level option. And start developing the idea, see how can that be done technically. And applied to Hatch, and that was one of the first slides or things that we learned about. So at the time, I didn't know anything about entrepreneurship per se, or have to take an idea or a solution, create a product and create a business out of it and take it to market. We started learning about systems thinking and how to present the idea and how to think about it as a business. This was one of the early sketches or kind of diagrams that I created for the Hatch program, and still a modified version of it is still on our website on the technology page. And here, where you can see, for example, this is the existing, it's a cross section through a building envelope. It's a curtain wall system, and then we add our system on top. It's very thin, so it's not as thick as here. And then a lot of things are happening inside the panel. And at the time, we called it Smart Panel. We didn't know what to come up with a name for an entire business. So it was a very interesting experience with the Hatch program. From there, I had to move to Houston. Unfortunately, after working on the idea for like a year, it got to a point when I needed to devote all my time to it. I thought it's technically possible. So we were, the technology was very, very risky because a number of things, a number of uncertainties had to be tested, and you needed to, build actual prototypes and build actual mock-ups, and that required funding. So at the time, I told my thesis advisor that I want to work on this. I'm not going to be able to do a traditional MArch thesis project about an architectural project. I wanted to work on this because this is what I want to continue with. And she told me at the time, yeah, I might not understand what you're, I have no experience in facade engineering, but I'll give you the green light, go do whatever you want, and I'll support you. So I quit my job in Boston. I was working at Kassas Freddie Architects and moved to Houston. We had family here. So we stayed in with them for like a year. And that allowed me to focus 100% of my time on this. So after a year, submitted the thesis project and applied for the patent before publishing the thesis as well. And, got the product to a point where it can be fabricated, like the first version of it can be fabricated. And from there, graduated and looked for an accelerator program. And at the time, the Cleantech Open was the largest accelerator for clean technology companies or clean technology startups. I applied, there was like a number of requirements, and you need to submit an executive summary and talk about the business and go-to-market strategy and all these things that I had no idea what they are. And started learning about it, and I told my wife, like, I'm going to apply. I don't even know if I'm going to be selected. They required 2 people. I was a solo founder at the time, so I had an advisor from Dubai join me, being a second, team member, and applied, got selected, and then won the regional award, and then ended up winning the national award after 6 months. And that was a great moment. I mean, never in a million years I would have imagined that this could happen. That put us on a map and gave us some funding. The award was like 50,000, non-dilutive. And one of the mentor team, he was an angel investor, and he ended up investing in the company, writing the first check even before winning, the award, like by a few weeks. So that was also a great moment, because at the time, after a year, I told my wife, look, if we don't end up raising funding, I'll have to put this on the shelf, and I have to go back and, go back to architecture, find a job, to be able to pay the bills and everything. And, just a few weeks before that happens, ended up winning and raised like 100,000. And then after the investors joined, other investors from the Central Texas Angel Network also decided to join, and we raised the first 250K. From there, I focused on validating the technology. Basically, there's a lot of things during my thesis I tried to validate in terms of running simulations, engineering studies, and also worked with a structural engineer, a friend of mine, to kind of validate a number of things. But still, there's so much you can do when you're trying to develop a new technology, because the standardized tests that are already in place, they don't cover what you're trying to do. So we had to work with one of the leading testing facilities here in the US, Intertech, to come up with modified versions of certain tests, and ended up building a number of prototypes and running tests before and after, given that it's a retrofit product. And at the time, there was a lot of uncertainties. The technology, even though we've went through and spent maybe 2-3 years before doing the test, everything could, fall apart. If the test didn't work, and we didn't pass the test, that's a major blow. And a lot of stakes, a lot of, people around me were like counting on this to work. And so that was a major turning point, literally as the diagram shows here. These were major turning points. So that was 2018. 2019, I had to demonstrate the technology now on an actual building, and that was another challenge. Like going to a building owner, telling him, "Hey, I want to try something new on your building." It's not an easy ask, and you wanted to look for people that are innovative and willing to take a risk and try new systems or new technologies. And that was when I entered a technology kind of competition, a clean tech competition in Boston by Greentown Labs in collaboration with Saint-Gobain, the leading company in terms of materials and building products, and ended up winning. And they offered us their research facility in Massachusetts to do the first installation. So we did the first installation in December 2019, and at the time, one of the customers, one of our existing customers now, he reached out to us and said, I'm very interested in what you're doing, but I want to see it on a building. And have you done anything like that? And we told them, give us just 2 weeks. We'll be installing this first pilot on a building in Massachusetts, and we'll send you the videos. So we sent them the videos, and they liked it, and they said, okay, let's do another trial with us in Seattle. And we did the trial. They liked it, and in less than a week, they decided to retrofit the rest of the single pane windows in that building in Seattle. And that was 2020. Despite the pandemic and everything, it was a lot of challenges already. But it was interesting that in the contract we had up to 3 months for them to decide whether they want to move forward with the rest of the building or not. And they decided in under a week, in a few days. We joked internally that we would spend more time sometimes buying something on Amazon than a few days. So that was a great kind of feedback from an actual customer on the project or the product. And right now we're in 2021. We've done, as I mentioned, projects in Boston, Seattle, Los Angeles, and now we're trying to expand to New York City because of the new regulations there and the incentives that are offered to building owners. And we ended up raising a new funding round, about 2 million, to be able to, continue our development and bring the technology to market. So that's like a quick overview of the journey. And, these are some of the slides that we show to, potential customers or, people to tell them more about the technology. So we've, let me show you just one thing about the system, how it is now. So this is how the Retrofit works. It's a very quick and easy kind of prefabricated product that gets attached on the glass and turns single pane windows into double pane or triple pane without having to remove, replace, drill, or alter any existing components. So here are some diagrams before and after, so you can see everything is happening here in a very tight space in less than 1 inch thickness. Here are some thermal images to show you the difference, where you can see the 10-degree difference in the surface temperature of the glass between a single pane window here and a double pane window with our product. We ended up, now we have like 7 issued and pending patents in the US, Canada, Europe, and China on the technology. And you can look here, a lot of times if you look at the product from outside, it looks like a very, very simple product. A lot of times people think it's just a glass panel. But really, once you zoom in and a cross section, you'll start to see the level of engineering that goes into the design of the system. And every one of these single components and materials is playing a major role in one or more aspects of the building or of the window performance, the structural integrity, condensation resistance, air leakage, water leakage, high wind load resistance, thermal insulation, sound dampening. All these that we went ahead and we tested them per these industry standards, and we did some modification. This is one of the very interesting tests. You can see here a caged airplane propeller with water sprinklers attached to it, and 4 feet away, and we will stand inside, and this can generate up to 140 miles per hour, and with water, so kind of simulating storm weather conditions. It was a scary test, because you'll be inside, you'll feel that this is gonna fall down at any moment. Very, very strong wind gusts blowing against it. This here was an accelerated weathering test, 4 months accelerated weathering test, taking the units from -40 to 140 degree Fahrenheit with UV applied 5 times a day, and then they put them in a high humidity chamber. Very, very stringent test. And here are some photos of the product that's installed. So you can see this is in Boston, this is in Seattle, this is in Los Angeles. It has a very limited visual impact. It's a very compact. It has a frameless look. So you can see here our original window. These are upgraded. This is original here. This is upgraded. These 6 have been upgraded. The rest is the original windows. These 2 have an energy efficient glass, just kind of entry level performance option. These 4 have thermochromic dynamic tinting glass that change the tints automatically. Here is a quick 15 seconds time lapse to show you. Focus on these 4 windows. You'll see that they're getting darker as the temperature rises of glass, and to kind of reduce the solar heat gain and improve thermal comfort inside the space. And then they go back to the original state. So this was one of the new glass technology that we can incorporate with our system. There is now transparent photovoltaic glass. You can see through and generates power. You can convert your building envelope into a micro power grid. There's vacuum insulated glass, a lot of other new technologies that are only available till today for new construction. And we're kind of offering them now the platform to be adopted by existing buildings. So this is a quick kind of overview of the company, the journey, and Len would love to either if you have any additional questions, or maybe we can dive into more of the journey in other areas? What do you think?
Well, I'm thinking of one of the comments that you made to me when we were just getting started the conversation about this session, and you said, if I knew then what I know now in terms of what it's going to take to start this business, I probably would have not moved forward, which I thought was pretty funny given the success you've had. And you just kept going. It just seemed as if you had a good idea. You had the knowledge. I mean, what impressed me as you're talking about the work you did as an architect is that your emphasis on facades and understanding facades is something that was ingrained in your training and your practice experience. When you look back and you think of the things that really mattered and where the successes really were, I think of what is it that you think helped convince investors? What is it that helped bring in the early adopters in terms of the project themselves?
Yeah, I mean, back to the first point you mentioned, if I knew the challenges that I was going to go through, especially in terms of, the technology, because we were, as I mentioned again, for people that don't really, facade engineering is not part of their expertise, it's hard to realize what kind of innovation is happening here, but we're pushing the boundaries on many fronts. And at the time, it's kind of almost impossible to know if it's going to work or not. And there's a lot of, it's different when you have a startup company developing a software application versus a hardware product. And for 2-3 years of pure development, there was a lot of risk. And, we had some moments, there were like literally blood, sweat, and tears in getting what you see here being, tested and built, and we broke a lot of prototypes. We've went through several, weeks of trying to solve the tolerance between one material and another material, and how this would be incorporated together, and how, even with the CNC machines that are already available in the industry, they what you see here is not to scale. It's very, very tiny. A lot of people at our fabrication partner, they call it the Swiss watch of curtain wall systems, because it's really fine and very, very tiny. So we had to go through a lot of iterations, and there would be some moments where, after months and months of development, and you build the first prototype, you test it, and that just doesn't work. You have to break it, and you have to go back again and figure out how to solve this. And it was a lot of challenges, and that's why, a lot of times I feel, entrepreneurs have some sort of naiveness because they don't know what's happening, and that's what keeps them going. If they knew, they would have said, you know what, it's not going to work. And we faced a lot of rejections at the beginning. Oh, this is not going to work. This is not going to work. And how are you going to do this? And, condensation is a big deal, and you're still going to have moisture traveling through, and no one was able to solve this. You get all of these, and you need to have thick skin, and just as if you're enjoying what you're doing and you're devoted to solving the idea, you'll have to make it work. And that's what we did. And then, finding champions at every step of the way is very, very important. Back to the journey slide. Here, for example, joining the Cleantech Open Accelerator was a major point, because on my own, I wouldn't have been able to pull this off. It's, you need to surround yourself with people that understand how to take a technology to market or build a company. So I, surrounded myself with a group of advisors who've done that, went through it, kind of tell you what you need to do and what's the scenario is going to happen, and advise you and provide the guidance. And then from here, especially with the first investor, because he was one of the mentor team, so I ended up working with him for like 6 months. and he saw that, he saw the dedication, and he invested while, I showed him my thesis. Basically, my master thesis turned into sort of like the first research book that I presented to the investors. And after 6 months, and talking, he kind of believed that I'll make it work, and things could work. And he took a bet. He took a risk, and invested basically in the idea, because we didn't have anything. It was just an idea on paper. But he was very influential on the Central Texas Angel Network. He was the board chair. So a lot of other investors kind of trusted his opinion. So when he invested, a few others joined. And you see, it's like that. And then, like that, finding the first pilot. If you ended up going to a traditional commercial real estate owner, and no one will give you their building. They don't want to be the first one to try a new technology. So we ended up, we wanted to work with an innovator. So Saint-Gobain is one of the top 100 innovative companies in the world. So they understood the risk, have done it before. They have vested interest in this, and they gave us the building, and that led to the next. So every time, finding champions at the right time is important.
How was it working with architects? Who I'm just curious. I know we've talked about how engineers were champions, but it had me thinking about the issue of risk and liability, and how architects who are decision makers or in the process of making design decisions, how did you win them over, or was that a struggle?
Well, so this is a tricky question, because it just happened today. We had a meeting with a major potential client, and they had the architect on board. And the way we developed this solution, and it has a new category in the building code. And the closest to it is storm windows. So storm windows are used mainly for residential, some of the low-rise commercial buildings. But they are a category that is exempt from having to comply with the requirements of altering or replacing windows. So it's like in building code, if you're not replacing any components, like the glass or the frame, it does not trigger code as an improvement to the building envelope. So an over-the-counter permit or express permit is enough in most jurisdictions. At the same time, so this really, as a process, you don't have any kind of building plans, sections, documents that need to be submitted to the city, because it's a standardized solution, it's a standardized system. At the same time, because it does not trigger code, it does not require architects. So we are able to go directly to the building owner and give them this solution, tell them about this solution, and they can adopt it. We act as a company, we act as a micro general contractor. And then we sub the installation to local installation companies, or we call them local installation partners. So far, we haven't had a project where architects were involved.
Interesting.
Yes, and but for example, when it comes now to major, you have a super high-rise building in New York City, and they want to do probably a more comprehensive renovation project, that not only the windows but everything. And then we can act as a subcontractor. So I spoke with a lot of architectural firms, especially in New York City, that focus on passive house, and they were super excited about this. But at the same time, you got to ask yourself, architects, some of them, they prefer to do a full facade replacement. And here you're telling them less is more. And, even though a lot of architects, they're interested in less is more, but tell them there's, a product that can kind of do the same, give you the same results as an entire replacement, and your input is minimal. And then it's a question, how would they, suggest that? And so a lot of times they would suggest more work, because that's how the industry is working, and that's how they're getting billed. It's billable per hour. So suggesting less work sometimes is, not a huge incentive to them unless they truly believe in, sustainability, energy efficiency, and, suggesting the most sustainable solutions for their customers. That's where, the challenge is. And, a lot of times we tell architects, if you're going to propose a full facade replacement, maybe 1 out of 10 customers are going to get rejected because they can't do that. It's very, very expensive.
Sure.
As a solution for just pure energy efficiency. Here's another solution that you can suggest that allows you to win more work. It might be less revenue for you, but it's better than nothing, and that increases the number of projects you're doing and accelerates the adoption of this technology, which in turn helps cities achieve their energy efficiency and emissions reduction targets faster. So this is what we're trying to tell architects a lot of times. And it's interesting. You'll find people that are super supportive, and you'll find people that they'll tell you, yeah, okay, but we prefer to do a full building renovation instead.
So what do you think, what are your next steps? What are you hoping that your next movements along the way will consist of?
So right now it's taking the technology to market and showing that there is a serious need for it. So right now we've hired our first employee in New York City, and the city there, we're working with Con Edison, the energy utility. They're offering very attractive incentives to adopt this solution, up to 30% of the total project cost. And with the local law 97, there's now, in 2 years, building owners will be facing steep fines if they don't improve the efficiency of their building. So we're trying to move into some of the major markets where this solution is needed. At the same time, we're expanding internationally. So we've been receiving a lot of interest in Canada and in Singapore. Just 2 days ago, we won a major competition and got selected by one of Asia's largest commercial real estate groups, which, by the way, was the developer of this project. When I was in 2015, I was working with Yoshi Safdie on this, and this was done by Capital Land, and didn't know that, or didn't imagine that in a few years we'll be partnering with them again to implement our solution at their properties. So they're super innovative. They're looking at improving the energy efficiency of their portfolio. They own properties here in the U.S. as well and all over the world. So this is what we're trying now. It's past the kind of technology validation, R&D, and we're trying now to bring it to market. I
was thinking about the conversation we had. I'm going to see if we can move on to because we had some interesting conversations about the BAC and the education you had, and you had some really interesting comments about what it takes to encourage entrepreneurship and certain elements of what we do, whether it's in practice or whether it's the academic side of the house. You just felt that there were things that were really critical to imparting to students the willingness to take risks and to really think a little bit about more than just a conventional career path. Exactly.
I mean, the ideas like Hatch or programs like Hatch, I think is really, really important. A lot of times, I tell a lot of investors that architects are great people when it comes to problem solving. But unfortunately, every new project is like a one-off prototype. They have to, go back again and try to solve problems again and again, similarly in a similar fashion every time, instead of trying maybe to come up with a solution that can be scalable and be adopted across more than just one building. So one of the things that I think is important is teaching entrepreneurship as a core class in the program, whether it's the MArch program or the BR program. And at the same time, trying to, maybe one of the studio projects solving an actual problem, like a real problem that architects and the building industry and the engineers are trying to solve, because we have the skills, we have the, a lot of the what it takes to be able to address a problem from a macro scale and also dive in and try to solve it and on the micro scale. Partnering with engineers, having this interdisciplinary discussion all the time is essential. And ideas like that would be very important to allow students to help them address some of the real world problems. If you go sometimes even to the Department of Energy, and there's like you have all of these requests for submittals or requests for ideas, and you look at who is submitting. A lot of times it's just either engineers or material scientists, while it's related to the building industry, but it's rare to find architects suggesting or proposing solutions. Sometimes it's because there's some very deep technical component, but partnering with the right people and having a team could help address some of the major challenges, especially with existing buildings. Now, I think there needs to be more focus. They're trying. The Department of Energy is trying to figure out solutions that could be fully integrated in creating a mass, a scalable renovation program for buildings. The president right now is trying to, in his $2 trillion climate change plan, is to renovate 4 million buildings. So to do these new, to bring those new technologies to market and help improve the efficiency of the existing building stock requires a lot of collaboration. And it starts at the school. I think it's with programs like Hatch and teaching entrepreneurship and how to take an idea and turn it into a product and turn it into an actual solution is important.
There's a question from a member of the audience. He says, I gather this applies to skyscrapers. Are there many existing towers that could achieve cost savings? And if so, how much per year?
Yeah, so we have a slide that shows a lot of times the cost versus benefits. And we now do internally energy analysis. We build energy models for any building in less than an hour. We've partnered with companies to be able to provide that to building owners. So you can see anywhere between 3.7 years payback all the way to 10 years, depending on the different attributes of the building. So single pane windows, if I have one thing, let me show you quickly. This was a presentation that I gave this morning to Tishman Speyer, and this is a slide that we showed, the INOVUES solution versus replacement. You can take a look at the Seagram building, for example, 375 Park Avenue, New York. If you want to replace your curtain wall, the payback is like 29 years. Here's the, for example, the Lever House, very famous. It was the subject of my thesis project. And you can see here the payback, 66 years versus 8 years. Similarly, this is the headquarters of JP Morgan Chase in New York City. They reached out to us. They said, send us a quote, even though it's double pane. And this is also from, this is a Tishman building. It's a double pane building that was upgraded in 2000. But still, a lot of the older buildings that have double pane, it's not the same as the double pane windows we have today in terms of performance. They lack significantly in performance. So it's still, kind of feasible to do it. And anything under 12 years for these kind of work, is considered feasible to building owners. So this is what we're trying to show them, that, hey, there's a solution now that you can adopt and improve the efficiency without having to pay dramatic, amount of money to be able to achieve that.
Yeah. I might get in trouble for this, but I wonder whether anyone at the BAC should be spoken with about our wonderful single glaze system.
Yeah, that would be great.
Why don't we open it up, there are other things that you'd want to talk about a little in terms of, I mean, we talked about getting students started and kind of fostering entrepreneurship. I know you talked about forming different partnerships, and other disciplines or other industries seem more willing to take some risks, and you've addressed how it is that you move them along to become more confident. Any other ideas or comments about things that you've learned along the way that you think are critical for entrepreneurs in general as they're talking with either funding sources or clients?
Well, the accelerator programs are really interesting for students to participate in. It's kind of low risk approach to test an idea. And there are a lot, especially in Boston now. There are a lot of programs from Greentown Lab to Mass Challenge that even just, I'd really recommend just go and attend those programs and pitch presentations and, see how other people are trying to solve problems.
Yes.
It's very exciting. When I was before joining the Cleantech Open, as architects, we have sort of like an understanding of the world, but we don't know how things are operating outside architecture or engineering or the building industry. And you go to those accelerator programs, and you see companies, whether in the software space or in the healthcare or in agriculture or a lot of other disciplines and industries, and you see how they're trying to solve problems and how they're going about problems and how they're taking new solutions or new ideas to market. It opens your eye to a lot of perspectives that are interesting, and I think it's necessary for architectural students to learn about the other disciplines.
Yes. No, and that there were earlier conversations about the nature of practice this morning, and there were several comments about things along these lines. Changing the model so that the work that's being done and the things that are being learned are much more transferable to starting something on your own. There was a second question. It has to do with the Tishman Speyer project. You said, is a 9.6-year payback for Tishman within their typical holding of a building? And obviously, you're looking at long-term investors who are not going to spin a property. So what are your thoughts about that in terms of winning that group over?
Well, so as we understood, Tishman invests in their buildings, and they care about the long-term hold of their properties. Now, you have a lot of different ownership structures when it comes to commercial real estate industry. You have, groups that want to flip the building in 3 to 5 years. So in that case, sometimes it is challenging. And that's where you have a triple net lease structure where, there's the split incentive barrier and you improve the energy performance of a building, and then it's the tenants who reap the benefits. But there's been a lot of movements now to address this using green leases, and now with the some attractive or kind of creative financing programs like the PACE program that has been adopted in New York City now recently, where you don't have to pay anything up front, and the financing for the project can be tied to the building, not to the owner. So even if you sell the building, it'll transition with it. So and you have owner-occupied buildings, of course, that own and occupy their buildings. And this is something we're trying to validate now. So, when you talk about a new solution, we started with validating the technology. Now we're trying to validate our go-to-market strategy and who's going to be the early adopters. Our thinking is that owner-occupied buildings are going to be the early adopters, but there is still a lot of incentives for even the building owners that want to flip the building in 3 to 5 years, because if you're improving the building envelope and in terms of the energy efficiency, thermal comfort, acoustic comfort, There's been studies that showed that, energy efficient buildings have higher sales prices, higher rent prices, higher occupancy rates. So this allows them to, cap the energy savings and increase the asset value and resell it again with that same increase. So there is some advantages to it. And even with the aesthetic improvement to buildings, we've talked to a lot of owners, and they said, if you can make my building look fresh and modern like the adjacent building, I can demand, higher rents and tell people that I've upgraded my mechanical equipment, which no one sees, but the building envelope everyone sees. So if it's modernized, that could help them invest in energy efficiency, despite having to flip the building in 3 to 5 years.
Who would have thought that these are conversations and approaches that you'd be taking as a student, or the level of understanding and expertise that you developed along the way? But obviously, it's necessary for you to move ahead and get that job.
It's a continuous learning experience.
Yes, well, you made the school proud. You've done some wonderful work. I remember a couple of months ago, I saw it was just an announcement of the update of some things that you were doing, and it was just amazing to see that you were making a go of it. More than that, you really were developing something that served a real need. I mean, I remember when you were talking about leaving Elkis and saying, I wanted to do something that I thought really made a difference, and that's something that you've held dear right from the onset, and that has driven your movement and your progress almost exclusively. Yeah.
Thank you so much, Lynn.
Thank you. We've got a couple of minutes, but if there are no other questions, I don't see we'll give it a little 30 seconds and see if anyone has a question. If not, we'll close it out. Well, thank you, Hannes. I've enjoyed this tremendously.
Likewise.
I think we're at a crossroads of the school where the timing with this conversation and the things that we are looking to do really play into this very well. I have a funny feeling that you're going to be tethered to our process as long as you're willing and able, because there's a real need. It's a real need.
Would love to.
Good.
Absolutely.
Good. Well, we've got a lot of witnesses.
Thank you, Len. Appreciate it
so much. It's been an enjoyable couple of weeks working with you, and I wish you the best.
Likewise, thank you so much, and thank you for this great opportunity. It's great to be back, and if anyone has any new questions or additional questions, please feel free to reach out.
Yeah, it's interviews, and do you want to post the?
So my email is my first name, Anas@inovues.com. So I just put it in the chat.
Good.
Yeah.